As always, you should only be here if you're really stuck, or if you've done it all yourself and you just want to check you're working. So go on, off you go. Go away, do it yourself properly, and then come back in a minute. And if you are stuck, don't watch the whole video. Treat it as lots of little hints by pausing the video, trying the next bit by yourself, and only watching me when you've really had a go on your own. The strange thing about this question is we've got two unknowns to find, a and b, but we're only given one equation. Normally if you want to find two unknowns, you need two equations, so we're going to need to find a way of creating two equations. The first step is to expand the left-hand side. Now we can see where the two equations are coming from. The real part on the left must be equal to the real part on the right, and the imaginary part on the left, 2ab, should be equal to the imaginary part on the right, minus 6. Remember, the imaginary part on the left is 2ab, not 2abi. This is the equation we get by equating real parts, and this one comes from equating the imaginary parts. We now have two simultaneous equations in two unknowns, so we should be able to solve for a and b. Label them 1 and 2. To solve, the easiest thing will be to substitute from equation 2 into equation 1. We express b in terms of a and simplify it. So now we can substitute for b into equation 1, and this is what we get. We're going to need a few lines of algebra to simplify this. I'm not going to put them all in, but you should do those for yourself. This is what you should have got, and we can see that it's a quadratic in a squared. So hopefully it will factorise. This is what you get, and don't forget the equals 0. So we get a squared equals 9 or a squared equals minus 1. Obviously from a squared equals 9 we can get a equals plus or minus 3. What about a squared equals minus 1? What a lot of students try to do is say therefore a equals plus or minus I. And this is very wrong. Why? Because the question said that a was a real number. We should write this note to explain why we're not going any further with this bit. So the only solutions for a are plus and minus 3. And what we should be able to do now is use the fact that b is minus 3 over a to find the values for b. But there's a potential problem. We need to think carefully. We know that a can be 3 or minus 3, and substituting back in, if a is 3, b will be minus 1, and if a is minus 3, b will be plus 1. So a lot of students would write the answer like this. But that's wrong. It's ambiguous. Someone could think, oh well, we can have a equals 3 and b equals 1. But that doesn't work, because we had the equation 2ab equals minus 6. So we need to write our answer in a different way. We need to pair up our a and b values properly. This is what we should have written. A equals 3 and b equals minus 1, or a equals minus 3 and b equals 1. Now we need to check. Starting with our first solution, here's how not to do the check. Substitute back into the original equation. Expand the brackets on the left. I squared is now going to be minus 1. And there we go. But no, look what we've done. It's awful. What have we really proved? All we've really proved is that 8 minus 6i equals 8 minus 6i. Well, we knew that already, so we've demonstrated nothing. This is not the way to do the check. It's faulty logic. Let's do the check properly. Instead of substituting into the whole equation, we're just going to substitute into the left-hand side and check that it equals the right-hand side. So there we go. If a equals 3 and b equals minus 1, then the left-hand side equals the right-hand side. So that's a proper check for our first solution. But we had two solutions, and when you've got two solutions, you've obviously got to check both of them, not just one. Or do we? Well, this is a very special sort of example. In this case, there's a good reason why we only need to check one solution. Ask me if you can't think what it is.